us discuss about the applications of signals and systems in ECG monitoring under design thinking. See, signals and systems form the foundation of basic biomedical engineering, especially monitoring and evaluation of the biomedical signals. See, biomedical engineering signals is nothing but basically is a ECG. Okay, we are going to analyze with the help of ECG signal. See, ECG signals are used to find the cardiac heart related issues, right, in terms of T waves, P waves and something waves. See, without these waves we can't eradicate this types of ECG monitoring. Now, under this design thinking concept, we are going to elaborate the empathy part, define part, ideate, prototype and testing.
I'm going to tell about the empathy part. So, empathy basically means collecting problem statements from the general public. So, in our project, we'll have to see means the general public will be patients, doctors or cardiologists, nurses, and then healthcare systems. So basically, patients who have heart problems will require regular and real-time monitoring for accurate data. So the complex designs of ECGs will make it difficult for them to know the raw data. So in that case, we need portable ECG monitoring systems. And in case of doctors and cardiologists, they will need to analyze the ECG data to perform diagnosis for cardiac arrest or heart rate variability and many other such heart diseases. And next, when we speak about nurses or technicians, they will come under doctors and cardiologists. So they will need to know how to set up the ECG monitors and easily take data from it for monitoring the patients. Then we have healthcare systems. So healthcare systems require cost-effective, scalable and real-time monitoring systems. This will reduce the medical load and enable telemedicine.
So I am going to define our problem statement. To design a ECG system that provides real-time noise-free cardiac monitoring. The system should be portable and reliable and user-friendly. Firstly, the challenges identified in our problem statement is this: the ECG signals are contaminated with the noise. So, for example, baseline band in the range of 0.15 to 0.3 Hz, it is mainly caused by the patient movement and breathing. Secondly, the muscle artifacts, it is in the range of 10 to 50 Hz. It is mainly caused by the skeletal movement in the patients. And power line interference, it is either 50 Hz or 60 Hz. It is caused by the nearby electrical devices. Apart from noise, the major difficulties in the ECG signals are difficulty in monitoring patients in the rural areas, and also it is needed for a real-time processing to analyze the patients. To overcome these challenges, the system must acquire a high signal to noise ratio, and it should have a hardware with a portable and reliable one to implement it with efficient analog and digital filters.
See, in this design thinking, to improve based on the ECG monitoring signal, we need to improve the signal to noise ratio, and also with the help of filtering these signals, or in case of low pass, high pass, band stop. Whatever the filter you are applying, you can convert with the help of the Fourier transform, you can convert the time domain sequence into frequency domain sequence.
I am going to discuss about ideate. In this ideate, analog preprocessing, signal conversions, and digital signal processing, and system integrations. In analog preprocessing, we use bandpass filter to isolate ECG signals, and we apply notch filters to suppress power line interference. And let us talk about system conversions. In system conversion, we use the method quantization sampling and anti-line filter alignment. In sampling, we use FIR filter and IR filters to avoid noise interpretation.
I'm going to talk about the prototype. Hardware components are electrodes and biopotential amplifiers, analog filters, ADC, microcontroller, and comfort, and doctors use diagnostic reliability.
I am here to conclude the case study on integration of signal systems on ECG monitoring. The recent thinking framework provides a structured framework for the solution like biomedical challenges like ECG monitoring. The signals and system concept includes filters, convolution and Fourier transform. These all helps to accurate and avoid noise-free signal acquisition, and also design thinking framework ensures the final product is medically reliable, technology innovative, and patient centered. Through this process in ECG monitoring, it helps to life-saving technique in biomedical field, and the synergy between the mathematics, engineering, and patient center helps the full potential of the signal system in real application.
Now, signals and systems plays a vital role in the field of biomedical engineering, especially this ECG monitoring signals. See, ECG monitoring signals is going to analyze the diagnostic test with the help of heart-related issues, right? In this design thinking concept, we are going to empathize from the users, and we are going to define whatever the biomedical signals we are having, right, with the help of these filters. That is nothing but FIR filters, IER filter, whatever may be the filters. With the help of filtering these signals, we are going to monitoring the ECG signals, right? Next one is here by using convolution, and then analog sampling. Sampling is the process of conversion from the analog signal into digital signals. First, we are going to analyze with the help of digital signals, right? And then we are going to quantize, and then based on the quantization, we are going to analyze with the help of anti-aliasing filter, and then we are finally we are concluding with the help of convolution part. Okay, convolution is nothing but here we are going to analyze only the digital signals, right? With the help of all these signals, analog ADC, analog to digital conversion process, and then with the help of all these filters, we are going to analyze the ECG signals, right? Now let us finish. It is the ECG signals is mainly based on the T waves, that is Q waves, T waves, etc. With the help of without these waves, we can't analyze the ECG signals, right? With the help of these filtering, and then convolution methods, and then signal processing, and then multi-rate signal processing, with the help of Fourier transform, we are going to analyze the ECG signals in signals and systems.